Hi. So today we're going to take the general form and point-slope form of an equation. So before we go on to this, I just want to remind you that we're dealing with equations. Now, an equation is a statement where the left-hand side is equal to the right-hand side. So in a grade 9 and 10 mind, often people say what you do to one side, you do to the other side. And that maintains this equality that exists between the left-hand side and the right-hand side. I'm going to maybe try to encourage you to think differently at some points. So we also say, oh, I would like x to be positive, so I'm going to move it over to the other side. And although that is true, although you move stuff over to the other side and it becomes magically the opposite, I really want to encourage you to think of what you're doing algebraically. It's these small little ideas of doing an operation to both sides rather than simply moving stuff. If you have this vocabulary where, for instance, if you have negative 3x is equal to negative 7, so if I move that over to the other side and the 7 over to the other side, they become the opposite. Although this works in practice, maybe try to build your algebra base. That will help you out in the long run. Enough blabbering about algebra. Let's move on. Let's get a start on things. The equation of a linear function can be written in any of three acceptable forms. The first form is the slope-intercept form. Everybody loves the slope-intercept form because if I'm asked what the slope is, it's m, b is my y-intercept. More important, I'm just going to make a little note. What is great about the slope-intercept form is it is easy to graph, right? That is awesome. I love to graph. Now, I'm going to talk about number 2, the general form. ax plus by is equal to c. This is called the general form. Now, you might be saying gross, but let's look at what the general form is. It's everything moved over to one side. In essence, that's all we have. And then we also have these additional conditions where a, b, and c are integers. So we have, for 2, we have, and by the way, they're capital for some reason, the coefficients of a, b, and c, which are in front of the x, y, and the constant, are element of the integers. So they're integer values. So hey, this is really good news for those who don't like fractions. So we have to think of the way out that and there's an additional condition where a has to be positive. So a is positive. So you can now notice how I wrote a is greater than 0. Really, a is positive. Just as long as you keep that in mind, really important. All right. Whoever thought of number 3, actually number 3 is not bad. But it's the point slope form. Y minus y1 is equal to m, open brackets, x minus x1, close brackets. So m represents the slope, and point xy, x1, y1 are any coordinates of a point on a line. So you out there carrying mathematics citizen probably are asking, well, why do we write things in several different ways? Number one, so incredibly beautiful to graph. Whenever I have a linear function, I try to put it into slope-intercept form if I can. Great to graph. 2, well, why do we have this general form? Well, general form, this idea of general form, it is a way that we get to compare functions. So here we're talking about lines, and as long as everybody has the same line, linear function, if everybody in the whole world writes it in general form, it has one unique way to write it. And by the way, same is true for slope-intercept form, but general form is something that we need to get used to for higher levels of functions. So if we move to quadratics, if we move to grade 11 and 12 stuff, we have this general form. General form is really lousy. Don't graph. Oh yeah, you can't graph. Terrible for graphing. So terrible for graphing, but really nice to look at. Number 3. Well, number 3 is kind of tricky, but can you graph this? Well, it is nice to graph from this. It's easy to graph, but it also has some challenges where it's not unique, right? If it's not, basically whoever looks at it has to do some work. Enough blathering, let's get on with the show.